Hi, we present cross-identity motion transfer for arbitrary objects through pose-attentive video reassembling. Our work introduces attention-based motion transfer approach and novel training scheme for the task. Motion transfer is a task of transferring motion between different subjects. As it's impossible to use pre-computed landmark annotation in the case of arbitrary objects, the network must learn to extract representations and transfer motion simultaneously. In motion transfer, the bigger the movement, the harder the problem becomes. As you can see in the first example, it is more difficult to create side view than to raise head slightly from the source image. Also, identity leakage is another major difficulty in motion transfer. In the second example, you can see the results that have mixed appearance of source and driving. Thus, isolating only pose from the driving video is another crucial issue in motion transfer. In order to handle the difficulty of synthesizing large motion, we propose a attention-based approach for motion transfer. Previous methods commonly take warping-based approach to extract representations and transfer motion at the same time. However, warping-based method is difficult to model large motion because computing warping flow becomes difficult. Source input is also limited to a single frame. To mitigate such problems, we propose a attention-based motion transfer approach that is effective in modeling large motion by searching the best source content in a non-local manner. And it makes our network utilize observations in various views and pose effectively. In addition, we propose cross-identity training scheme to prevent identity leakage. Even though the actual task is to transfer poses between different subjects, previous methods are usually trained by transferring poses on the same subject. In this scheme, it is difficult to distinguish between poses and shapes because there are no hints about it. We solve the problem by training network using different identities as in real testing scenario. In the new training scheme, we make pseudo-driving frame for cross-identity training, and it is effective in preserving identity-specific property. This is the overview of our framework. First, our network extracts a pose and appearance pair from a source image. Our source image is processed independently with the shared network. Next, driving pose is extracted using a shared embedding network. With the driving pose, it retrieves appearance correspondent to the pose. This module aggregates relevant appearance based on pose similarity. Finally, our network generates a new image in the driving pose. Our network is trained using both self-reconstruction loss and cross-identity reconstruction loss. Different from the self-reconstruction loss that uses same subjects per training, our cross-identity training uses different subjects. At first, it makes pseudo-driving image using two subjects. And with the pseudo-driving, it performs second generation using also different identities. The final generated image is compared with the first driving to give pixel-level reconstruction loss. This is a qualitative comparison with other motion transfer methods for arbitrary objects. For quantitative comparison, we measure following metrics on self-reconstruction and cross-identity motion transfer. FID scores measure the quality of generated image, and AKD and AED scores show the degree of motion and identity preservation. In both Select and Bear, our network outperforms our baselines in our metrics. In Taichi HD, however, our results are worse than those of first order, especially for self-reconstruction. We also conduct user study as shown in the second table, and our results are preferred over previous warping-based method on all datasets. We also compare our method with multi-source methods that use spatial landmark annotations. To the best of our knowledge, we are not aware of any multi-source motion transfer methods designed for arbitrary objects. Our method significantly outperforms extraface and is competitive to neural head. These are our motion transfer results using multiple frames. We conduct a evaluation study on Pose-Attentive retrieval module. As a replacement of our module, we make a baseline that concatenates the appearance picture of a single source. We also make multi-source alternatives based on nearest pose and averaging. We see that our method outperforms our baselines in our metrics by a wide margin. We conduct an evaluation study on the cross-identity training scheme. When using cross-identity training, our method gets performance gain in both of quantitative and qualitative results. To understand the round representation of our method, we visualize the round keypoints and attention maps. When given multiple source frames, we can see that a source content in a similar pose is more activated. This is the summary of our work. We propose a attention-based motion transfer approach, and it can utilize variable number of source images that is beneficial in synthesizing various views. Finally, we address the issue of identity leakage problem and solve the problem using cross-identity training. Thanks for watching.